Hello, and welcome back to Chemically Doped by AIChE-VIT, a podcast where curiosity meets chemistry. I'm Josh, joined by my co host Sean. Today, we're diving into a challenge every industry faces, but few really understand: industrial wastewater management.
Now, when we're talking about industrial wastewater management, it's a challenge that every industry has to face. Like, since the Industrial Revolution, we have seen huge advancements in how it's treated, but also plenty of problems that are yet to be faced.
To help us explore this further, we are joined by a very special guest today, Dr. Samson Ponselvam, Vice President and Head of EHS and ESG at Viyash Life Science Private and Limited. He's an accomplished EHS and sustainability leader with extensive experience across various industries such as API, formulations, oil and gas, and tanneries. With such a wide background, he brings a unique perspective to today's discussion.
It's a real honor to have you on the show, sir. Like, how does it feel to be part of Chemically Doped?
Really, so I'm much excited to be part of this particular podcast because I'm really fascinated about teaching this particular area, which is highly emerging and quite important in this age, and especially with you students fraternity. So I'll be really, really feel so elated to have a discussion on this topic, which is mostly avoided these days, but still highly important. Yeah.
That's something nice to hear from you, sir. Like, to start things off, now, from your experience, what really happens during industrial wastewater management? And over the years, which methods have stood out to you as the most effective in dealing with industrial wastewater?
See, I'll put it this way. The other day I was visiting a paper mill. Everybody, as a student, of course, you'll be having textbooks, notebooks, and everything is recorded in that. So it is bright, white, and right. And actually, when you visit the factory, all this paper will be so glossy. But if you take a peep behind the factory, then you will see the black liquor. So the effluent that is produced from a paper mill, it is called black liquor. Many times we understand only all about the products and the services, but what is going behind, many times we do not know. There's a famous adage which goes like this, right? Face is the index of mind. Same way for any industry, effluent treatment plant or ETP is the index of the industry. Those were days where people thought wastewater treatment is a waste treatment, right? Pouring the money down the drain by unnecessarily treating. This was the mentality. There is a huge scope because the awareness, the public awareness, and the customer importance, and the public litigation and the regulatory requirements has become really huge. And now India becoming a kind of world global player. Unless we treat our effluent in a responsible way, we cannot really compete with the global market, and this has become a competitive market advantage. Yeah. So that's how I put it, the kind of importance it takes, because every drop tells a tale, and not all tales are easy to tell, they call it.
It's quite interesting on how you are talking about how we neglect the waste and the byproducts, but only focus on the products. So, we would like to have more insights on how do you measure the waste, how do you, analyze, how do you differentiate waste, and how do you have specific methods so that you can treat the wastewater. So, what are your analysis and what are your technical parameters and tests which you use?
Yeah, before I jump into the testing aspect or the measuring aspect, I will give you a perspective. Say, we need to focus on the source, the start of the pipe rather than the end of the pipe. What do I mean? When you go to the doctor, right? So you take a blood test and you have some issues in your blood, say being diabetic or something else. Just because you have an issue in your blood, you don't go and clean your blood. The doctor says, manage your diet, what you eat, what you feed. So, the same way, many times people make this mistake of doing all this jugglery in the effluent treatment plant, totally neglecting what is coming in, what is the feed, what is happening at the source. As we do with the doctor, the same way we need to manage the diets, the feed that is given to the ETP. So I never call waste as a waste unless it is wasted as a waste, right? It is a misplaced resource. So everything that is coming to the effluent treatment plant is a resource that is wasted or misplaced or put down in the drain. We are first of all wasting the resource by allowing that to go down the drain. And secondly, we are spending money to recover that wastewater, treat that wastewater, and manage that wastewater. So we are paying double or triple by unnecessarily allowing that. Okay, having said that, coming to your question, you said that how do we measure what all we need to test? The
Yes,
water
sir.
we use for washing our hands, is that a clear water? Yes. But have you noticed that the same water which is going out of your house, if it is stagnated for a couple of days, how it will become? It will become black. It will become septic. What does it mean? That means, okay, so your wastewater is containing some organic load, organic material, which can be measured as chemical oxygen demand or biological oxygen demand. What do I mean by that? Okay, when these organics come in the water, this will be attacked by the microorganisms. For microorganisms to act upon this biological demand or the organic load, it needs oxygen. If you do not have enough oxygen, then it becomes black. At the same time, the same water, what is going out of your bathroom, going out of your house, the sewage, if you're going to give enough aeration, then it will become very good for the microorganisms to work on that, feed on that, and digest that. So, depending upon the type of wastewater, you need to go for the analysis. So, if it is organic, what? If it is inorganic, what? If it is having heavy metal related pollution, then that kind of thing. At the same time, against what you are going to do that. So, depending upon your usage point, for example, I have got to use this water in the cooling tower or boiler or in the sea or in a river, or you're going to put it in a kind of lake in the place where you can swim even. So depending upon that, your treated water quality parameters changes. So depending upon the regulatory requirements, we need to go for next level of treatment. So that's what I see. It is not a fixed one. Of course, regulatory aspect, there are some parameters like pH, TDS, COD, BOD, right? So these are the key parameters, though they have another 28 parameters to check for. If you take a food industry, a beverage industry, where you have organic load, then your key focus should be on the COD and BOD. And if that wastewater has good amount of suspended solids, then you will look for total suspended solids, right? And then if you have many good amount of inorganics, then you will talk about TDS, total dissolved solids. In that also, organic how much, inorganic how much.
Okay, so actually, very good to learn for us chemical engineers about this much test and process involved in wastewater management, and with someone who's actually in close quarters with several industries. Like, can I know what are some of the biggest challenges you have seen in managing this wastewater, and like how have your experience shaped the way you approach it?
Okay, so if I would say the general approach in a wastewater treatment is like this. I would say rather a stereotype how it goes. So initially, when a wastewater is generated, it can have suspended solids, right? If you see the municipal wastewater, so since we know that we are seeing, that's why I'm taking the example, common examples. So in your sewage, you will have many solids, right? Grit. So first treatment they give for any wastewater treatment is the primary treatment, which consists of suspended solids removal. How do they remove the suspended solids? If you keep the water stagnant, static, automatically on gravity, it will settle. That is sedimentation. And bigger particles, for that you will have a kind of sieve or a bar screen which will screen bigger particles, small screen smaller particles. This is a primary treatment. Also they will neutralize, because always before we use it for microbiological treatment or any other treatment, they make it neutral so that we can easily handle that. So pH adjustment, they have to do it, neutralization they call it. And also morning you will have one strength, afternoon you will have another strength, in the peak you will have a different strength. So you need to equalize that and make it really consistent. So they call it equalization, neutralization, sedimentation. So these things come under a category called primary treatments. Okay. After primary treatment, when all the suspended solids are fairly removed, then it goes to secondary treatments. Secondary treatment, what exactly happens? So usually it refers to the biological treatments. So biological treatment, there are so many technologies. They call it activated sludge process or sequential bioreactor or soil biotechnology. So biox, media. So there are so many varieties. So primarily what happens, these suspended solids free effluent, which is having good amount of organic material, which is the food for microorganisms. What exactly we do? We take a tank, in that we put the wastewater, aerate it. This air is the oxygen for the microorganisms, and the organic load, the COD, BOD, right? The BOD part mainly is the food for the microorganisms. So the microorganisms feed on the food using the oxygen in the air. They break that down into simpler byproducts, into CO2, right? This is how the complex organic dirt waste material is degraded. So the COD and BOD reduces. The third treatment is, they call it tertiary treatment, where the suspended solids, the microorganisms related things has to be filtered off, right? So where they use sand filter, carbon filter, right? And these days many automated systems also have cartridge filter kind of thing. And now this tertiary treatment is the pre-treatment for the quaternary or the advanced treatment techniques. So what we do, we call it zero liquid discharge facilities. So whatever wastewater is coming, we convert that into usable, recyclable, treated water, and whatever solids that are coming, that will be concentrated and produced as sludge, which will be disposed to cement industries, or it can be used as byproduct or raw material, depending upon the constituents of that sludge. Chemical engineers, you definitely would appreciate what is flow mechanics, what is thermodynamics, right? And your heat exchangers and say distillation plants. So you can explore. So these things, chemical engineers, they understand much, because many of these industries, processing industries, food industries, chemical industries, they use in the process, whereas these are used in the effluent treatment plant also these days. This is called multiple effect evaporator plant, where your effluent is the feed and your condensate is the byproduct, and your solids, that will be the sludge that will be disposed. So as you said, the challenge here is the solvents, which you need to separately take it out, right? And some once we get this one, you will have the we call it condensate water that can be further treated comfortably in the biological system, which I explained earlier. At the same time, you will have a stream which is having only TDS. Have you heard of DM plant, demineralizing plant, where they will use water for boiler with low hardness? So in that process, you will generate good amount of highly salty effluents. This salty effluent, you have to put it in RO, which only can treat the TDS. So that TDS will be totally removed. That permeate can be used comfortably back. Okay, these are some challenges based on the constituents. Okay, some other challenges with respect to people and practices. If I'm in the production, I will say I'm least bothered about effluent treatment plant. So I want only production. So I'll put down the drain whatever I don't like. So I can put solvents, I can put some solids, I can put anything which I don't like or which I want to shortcut. I don't want to have the discipline. So this becomes a biggest problem, biggest challenge. So this is usually the disciplinary challenge with people, with systems. So we will have many sensors, we'll have many checks and balances before they send the effluent. We'll check for the COD, pH kind of thing, some quick tests so that we'll, oh, you cannot send beyond this level. Then we'll say that oh, this treatment plant can withstand only this much, it can treat this much. So we'll dilute that. But at the same time, you need to take that in caution. Many people think dilution is the solution for pollution. No, we cannot use water to keep on diluting. No. So we need to have these technologies to extract water, not to use water to dilute and pollute or use the uh, non-renewable resource rather.
Now, the last question for the day, like this is for the students and the young engineers who are listening in. Like, how can they start contributing towards wastewater management, like with the knowledge they are getting from the textbook? And from your perspective, what is the job market and the scope opportunities for the chemical engineers in India as well as like abroad as well? And finally, what kind of innovations do you want them to bring so that it might be useful for the next generation?
When you really to really design, you need for a chemical related things because it has all these things what I talked about thermodynamics, right? So you need to have the chemistry knowledge, chemical engineering knowledge. When you are talking about secondary treatment, that's a biological treatment. So you need to have the environmental and microbiology understanding, right? And these are all related to regulatory and other stuff. So you need to have the regulatory understanding. Not only technical aspect, you need to manage all these things. This is highly skilled area in every aspect. So we need to have a management understanding. But having said that one, I would appreciate a chemical engineer have upper hand in this aspect. A chemical engineer who understands this process can have a better design of the characteristics of the effluent because he understands the process. You understand the manufacturing process, so you will know what kind of effluent, what kind of characteristics. So how should I? So you can match the industry, wastewater, and the effluent treatment process. So you can have a better understanding of these things. So chemical engineers really you can excel in this one. So when you have this practical knowledge of chemical industry and some practical knowledge what you gain from your existing systems, you are ready to hit the market.
Thank you for that. We understood a lot of
Yeah.
things. You first talked about the product being the more in focus, then you talked about the effluent, then you've gone about many different techniques such as EMME, MEE, and ZLD. Uh, it's been quite an insightful session for all of us so that we understand how you treat effluent and what is the thinking behind that. And we really decoded the effluent treatment process. Uh, on behalf of AIChE-VIT, we sincerely thank our guest for sharing his invaluable knowledge and insights to our listeners. And listeners, if you found this episode interesting, don't forget to like, share, and subscribe to Chemically Dope for more conversations at the intersection of chemistry, engineering, and innovation. Thank you.
Thank you. Appreciate all the best.